Hello there, welcome back to Dynamics Foundations. This is video 4. In video 3 we did a kinematics problem and we did part 1 of it, and now we are going to finish that problem. So in this problem what we're looking to do is find the position of a ball that was launched from point 0 when it gets to point 2. In other words, how long does it take to get there, time 0 to 2, and how far is that? We're going to do that. First I need to do some of the unit conversions. I think I'm going to do everything in feet and seconds, and I've got 100 meters there, so I need to convert meters to feet, and I'll do some of my unit conversions here. Step 3, unit conversions. You can often ask Siri how to do this, but I have 100 meters, so this is y0 equals 100 meters, and there are 3.28 feet in every 1 meter, so y0 is 328 feet. Let's see what Siri has to say. Convert 100 meters to feet.
That would be 328.08 feet.
All right, 328.08. We'll go with that. I also am going to need the velocity in the y direction at point 0 and the velocity in the x. Let's go ahead and get v0. It's right now 60 miles per hour. I'm going to do that differently. 60 miles in 1 hour. There are 5,280 feet in a mile, and there in 1 hour there are 60 times 60, or 3,600 seconds. So the hours will cancel, the miles will cancel, and we'll get an answer of feet per second. And to do that math, I believe you get 88 feet per second. Let's talk to Siri. Convert 60...
That may be beyond...
Oh, I pushed too hard. Convert 60...
Good afternoon.
Oh, now Siri. Convert 60 miles per hour to feet per second.
The answer is 88 feet per second.
There we go. All right, so now in step 4, we're just doing the math here. We're going to solve this first equation. Where y2 is 0 and y initial is 328 feet, and the initial velocity in the y direction is 88 feet per second times the sine of 30 degrees times the time from 0 to 2 plus 1/2 times negative 32.2 feet per second times time. And we're going to solve this for time. And a good calculator will do this for you. I'm going to flip over here to Wolfram Alpha, which is an online equation solver. And I'm going to solve 0 equals 328 plus 88 times sine of 30 degrees times t plus 0.5 times negative 32.2 times t squared. And I should just be able to hit solve. And I want this in the approximate forms. I need to hit solve again. And I get two different answers. Why is it not giving me my approximates? Oh, go away. Go back, back, back. This is the total form in the with radicals and so on. I did this just a few minutes ago, and now it's fighting me. Well, if we look at the number line here, it is two answers because it's a quadratic. I have 6 seconds, or I have negative 3.2 seconds. I think we want this to happen at 6 seconds. We don't want it to happen before we've launched the ball. So this is 6 seconds, and if we were to put in 4 over 161 times the quantity 55 plus the square root of 36,030, we would get this 6 seconds. I just started using this solver. I prefer to use a TI Voyage calculator. I assumed that this would give me an answer that had the actual numbers, but it didn't. I'm not going to waste our time. Head back over here. T from 0 to 2 is 6 seconds. Now, if we put that 6 seconds into equation 2, do that down here, we'll see that x2 is equal to 0 plus 88 times the cosine of 30 degrees times 6 seconds plus, and remember now this is 0, so plus 0. So we don't need to use a solver here. We can simply just multiply 88 times the cosine of 30 times 6 seconds, and I'm going to use my iPhone here to do that. 88 times cosine of 30 times 6. I get 457 feet. X2 is 457 feet. So there we have it. And a worked out example of a 2D kinematics problem. This should be familiar to you from when you've had physics. The Khan Academy has several other worked out examples, and when we get further into the course, we will also be doing more in-depth examples of 2D kinematics.